Welcome to our first little mini lecture for Chapter 6, The Restless Sky, Severe Storms, and Storm Systems. We're going to start off this chapter with a very basic concept that in and of itself really isn't all that exciting, and that is the concept of air masses. Air masses aren't super involved. When a cold air mass moves over your location, it gets cold. When a warm air mass moves over your location, things warm up. But when different air masses meet, things can start to get really interesting really fast. Air masses are really large masses of air that have uniform characteristics of humidity and temperature throughout. Sort of like an air parcel, but at a much, much larger scale. Air masses can cover many hundreds or even thousands of square miles. These characteristics of humidity and temperature are determined by the source region over which that air mass originally formed. So let's stop and think about that. Think about a source region. What about a source region would contribute to the humidity and temperature characteristics of an air mass? We're concerned about humidity and temperature. So what about Earth's surface is going to affect humidity? Well, when it comes to the Earth's surface, we basically have two choices of what's going on here. We either have land or we have water. Which of those is going to cause more humidity in an air mass, do you think? What do you suppose would affect temperature? Maybe where you're at on the surface of the planet? If you're at high latitudes, chances are you're going to be cold, and if you're at lower latitudes, say around the equator, chances are you're going to be pretty warm, right? Well, we actually have a classification system for air masses. When we classify air masses, we do so based on those two things. First of all, did they form over land or water? And then second, where on Earth did they form? Because that's going to tell us a lot about those temperature characteristics. Well, let's start with that humidity aspect. Air masses that form over water are going to be humid air masses. We call air masses that form over water maritime air masses. Notice it is in red. That's because it is important, much like the one below it, which is continental air masses. Air masses that form over land are continental air masses, and as you would expect, these tend to be much drier. If we start looking at the temperature aspect, well, we've got a couple of different choices here. We can classify the air mass based on what region it formed over, and we classify these as either polar, tropical, Arctic, equatorial, or Antarctic. This is obviously going to tell us about the temperature of the air mass, and I'm guessing you can probably tell what that temperature will be based on where that location is. So here's how this works. When we classify these air masses, we use a kind of shorthand, abbreviations, just to make it easier to write this down. Our little abbreviations have two parts. We have first a lowercase m or c for either maritime or continental, based on those humidity characteristics, and that is followed by an uppercase classification based on temperature. Capital P for polar, capital T for tropical, capital A for Arctic, you get it. For example, an MT air mass stands for maritime tropical. It's going to be wet and it's going to be warm. CP stands for continental polar. It is going to be dry and it is going to be cold. Here we have air mass types that affect much of the United States. The United States receives several different air mass types from surrounding air source regions. Here we have a handy-dandy little table from your textbook that summarizes the characteristics of each of these air masses that affects the U.S. for you. Note that for the remainder of this chapter, we are most interested in the two air masses I have highlighted here. I mentioned them earlier, continental polar and maritime tropical. So let's spend a little bit of time on each of those. Also, I'm not going to talk to you about the continental Arctic because it's so similar to the continental polar. Well, let's get into it. Our first one is continental polar, the continental polar air mass. These occur only in the northern hemisphere because we have that massive land mass. They are most developed in the wintertime. In the cold winter months, they are a major player in middle and high latitude weather. Because cold, dense continental polar air will come in and displace really warm, wet air, this causes the air to lift and cool and condense. Remember those lifting mechanisms we talked about before? Well, this is where frontal lifting comes in, where you will see some really cold, dry air come in and move into, say, Louisiana, where it's warm and wet and you get a big thunderstorm. Now, the reason we don't see this in the southern hemisphere is because the southern hemisphere lacks the necessary continental land masses at high latitudes to create this type of air mass. And then we have another polar air mass, the maritime polar. This one forms over the northern oceans, so it's maritime. Remember, over oceans, maritime. It has a lot of moisture in it compared to the continental polar. So in this case, it is cold, it is moist, and it is unstable. Because it's cold, it can't hold a lot of moisture, but being over an ocean is enough to saturate it. Think Seattle, Washington. It's cool and it rains all the time. Well, that's a maritime polar air mass. These are also called Aleutian or Icelandic lows, depending on which ocean they're in. We call it an Icelandic low if it's in the Atlantic Ocean near Iceland, or an Aleutian low if it's in the Pacific Ocean near Alaska. We also have two maritime tropical air masses, maritime wet and tropical hot. There are two that influence North America. One of them forms by Louisiana. It is formed over the Gulf Coast, over the Gulf of Mexico, and the Atlantic. This is a maritime tropical influence that shows up in the eastern United States, including all of the southeast, the Gulf Coast states, and all the way up into the Midwest. It is unstable, and it is very active from late spring to early fall. This is one of our two big ones we want to remember for the exam. Over the Pacific, we get stable to conditionally unstable maritime tropical conditions. This is because the Pacific is so cold that it doesn't get nearly as much water in it as the maritime tropical over the Atlantic. It is wet, so it can rain, just not nearly as much or with as much intensity as the maritime tropical one in the southeastern U.S. In this part of the world, you get some lower than average precipitation rates in general in the western United States, just because of that reason. And then our final one that we're going to look at is continental tropical. This one is unique because it only forms in the summertime when the continental area landmass warms up enough. It forms over Mexico, but it extends upward into the United States. In Texas, it brings very hot and dry air into different regions. And it can create some really impressive thunderstorms because it provides a very sharp gradient in the dew point. It typically extends about halfway across Texas. Now think about that for a minute. If you've ever driven through Texas, you know that the western side of Texas is very dry, and the eastern side, the other side of Texas, can be pretty wet. This is why, because of that influence of the continental tropical air mass and how far it extends across Texas. Because we have these two very different air masses meeting over Texas, about halfway through, we have that dry, warm continental tropical coming up from Mexico, and that warm, wet maritime tropical coming in from the Gulf of Mexico. When they meet together, they create a front, and this can lead to some really impressive thunderstorms, a special kind of thunderstorms called dry lines thunderstorms. There are some things that are just a little bit different in Texas, and this is one of them. And one very important thing to keep in mind is that air masses change as they move. They don't retain the characteristics of that source region over which they formed forever, because as they travel across different land surfaces and different regions, they're going to start to pick up some of the characteristics of the surfaces over which they're traveling. You might imagine that if a cold, dry air mass moves over a warm, wet surface, it's going to start to change its characteristics. This is something we call air mass modification. And this can change the weather of an area dramatically as that air mass moves. For example, when you are a maritime tropical Gulf air mass, the type that comes from down near us in Louisiana, and you are carrying humidity to Chicago and on to Canada and Winnipeg, well, you might have started out a maritime tropical air mass, but as it continues, that air mass continues moving northward, it gradually loses its warmth and humidity as it moves. Another example is the phenomenon of what is called lake effect snow. This occurs when a continental polar air mass, one of those cold, dry ones, changes as it moves south and east over each of the Great Lakes. When this happens, we can get really heavy snow on the leeward sides of the lakes. This graphic is trying to show all of that. Here the red arrows are representing a continental polar air mass moving over the Great Lakes. Now, the Great Lakes would not feel warm in the wintertime were you foolish enough to step into them. However, compared to the frigid air masses coming out of Canada, they're pretty warm. Remember that water takes a long time to change temperature because of its high specific heat. So the water in the Great Lakes, even in winter, is still hanging on to some of that heat absorbed over the summer. When that continental polar air mass passing over goes over that warmer lake, it in turn is going to absorb some of that warmth and moisture coming off the lakes. When it hits the other side of the lake, it is going to wind up creating moisture-filled clouds on the leeward side, and then you can wind up with these huge amounts of snowfall. Okay, we are going to wrap it up here, but first I would like you to remember your 4 lifting mechanisms that we talked about previously. First, we have convergent lifting. When air comes together, it collides and it moves up. Then we have convection, convective lifting, when warm air rises. We have orographic lifting, when air hits a mountain and is forced upward. And then finally we have frontal lifting, when vastly different temperatures move into a new region and come into contact with each other. Here I want you to think air mass movement. So hold on to that last thought, because we are going to need it moving forward into our next topic, which is thunderstorms. See you in the next video.